my talk. So yeah, we'll talk about exposing spies on macOS. My name is Patrick Wardle. I've worked at a bunch of acronym places. I'm currently the Chief Security Researcher at SYNAC. So at SYNAC, we run managed bug bounty programs with vetted security researchers. Basically, in short, we think that currently researchers or hackers in conjunction with software and technology is the best way to find vulnerabilities. So if you're a security researcher or a hacker, you can sign up with us kind of as a freelancer and basically get paid to find bugs in our customers' mobile apps, IoT devices, and network endpoints. All right, so what are we going to talk about today? Well, after discussing some background concepts, we're going to dive into talking about some Mac malware that uses the mic and or webcam to spy on its victims. We'll then talk about a relatively new attack or capability that could allow malware to record the user while the webcam is being used legitimately without detection. And then finally, we're going to talk about how to detect and thwart this attack with a new tool I wrote called Oversight. All right, so let's start off with some background concepts. So one of the most insidious actions of a cyber attack is abusing the video or audio capabilities of an infected host to record an unknowing user. So who's hacking webcams? For one, hackers are doing it, often for their own perversion. There was a great article that was written, I believe it was in Ars a few years ago, discussing this group or forum of hackers, mostly males, that would try to hack all these computers around the world and hope that they were female so that they could then record the females as doing all sorts of stuff. It's also shown up in television. I realize this is fictional, but I think it represents a very realistic scenario. So there's a Netflix show called Black Mirror, and one of the episodes, these hackers hacked this teenage boy's computer, filmed him while he was pleasuring himself. And then the rest of the episode is how they were able to blackmail him to do all sorts of horrible things because they had hacked his webcam and had footage of him. And again, yes, this is fiction, but there have been cases where hackers have recorded people doing things that they would rather not have be public, and then either trying to or blackmailing them to do all sorts of stuff. So kind of intense. Obviously, nation states and governments are interested in hacking computers and using the audio or video capabilities of the infected hosts for different reasons, right? I don't think the NSA wants to see you naked, but they probably are interested in what you are saying or what is being said around you. So, I mean, imagine if, Donald Trump used a laptop. I'm not sure he's smart enough to, but if we assume that he did and you were able to hack it and then turn on his mic to hear what was being said around him, perhaps in the White House, you could see how that would be a very interesting capability that nation states and governments would obviously be very interested in. All right, so shortly we'll look at some Mac malware specimens that are able to access the webcam and mic to record the users, and I'll also discuss an attack that allows us to piggyback off legitimate webcam sessions. But first, let's talk about how to programmatically access the webcam or mic on macOS. Turns out it's pretty easy to do. You can use the AV Foundation framework. This was released not that long ago by Apple. And as the slide shows, you can see it sits in an interesting place in kind of the software stack. So it's below the application level, but above some of the older, more lower level complex frameworks. So it's in a really good position because it's high enough in the stack that it's able to abstract out a lot of the details, but it's also low enough that it's pretty powerful. So what can we use the AV Foundation for? Oops, go back really quick. So the main thing for the purpose of this talk is we can use it to enumerate attached or built-in devices. So via the AV Foundation, and we'll show code to do this, you can get access to the default webcam, attached webcams, the built-in microphones, etc. And then once you have a reference to this device, you can start recording off them. Now you might be wondering, do you have to have any special permissions in order to access the webcam or the mic if you want to, say, record the user? Well, it turns out if you are a sandboxed application, so one from the Mac App Store, you have to have a special entitlement, and that's the com.apple.security.device.camera entitlement. But it turns out this is an entitlement you can give your own app, right? It doesn't have to come from Apple. So when you're building an app, if you want to be distributed in the Mac App Store, you've got to make sure that it's sandboxed. And then once you've made that setting, there's an option to check the camera. Once you check that, that will add the necessary entitlement to your application. Then you publish this to the Mac App Store, and when users download it, the application will be able to access the webcam. Now, we might hope that Apple will verify this. You know, if you are just a calculator application and you have this entitlement to access the webcam, you know, maybe Apple will deny it, but I haven't heard any instances of that. So it's pretty much not a showstopper. Now, if you're distributed outside the Mac App Store, which most, if not all, Mac malware is, you don't have to have any special entitlements. So once you execute on the box, you can access the mic or the webcam without any pop-ups or anything. Now, of course, once you do record off the webcam, and we'll talk about this a little more, an LED indicator light will come on. All right, so now we'll walk through a simple example of programmatically how to record video off the webcam on macOS. So this is based on an example that's on GitHub called Video Snap. We'll see it's pretty straightforward. So we're going to start at the beginning. We have our main function, and the main function pretty much does three things. The first thing it does, it sets up a signal handler. And this is just because this is a command line utility, and so we want a way to be able to stop it while it's executing. So the signal handler just accepts Control-C from the command line and basically just calls stop recording. Because as we'll see, we'll have to do some cleanup once the user exits to flush out the remaining audio and video and then save it to disk. So once we've set up our signal handler, we allocate a video snap object and call record, and we'll dive into showing what this does. And then once that's recording off in the background, we just spin in the main loop. In Objective-C, if you want the main thread to just kind of keep running, you get access to its run loop and then just call run on it. So it won't exit. It'll allow the recording code in the background to keep running. All right, so here is the implementation of the video snap class, specifically the record method. And we can see the first thing it does is it gets the default video device. After that, it creates a bunch of objects. It creates an AV capture session object, an AV capture movie file output object, and an AV capture device input object. It then adds both of these to the session and calls start running and then start recording to output file URL. The end result is now this code will be recording off the webcam and writing the results to the file that you specify. And yes, the LED indicator light will come on. Now we have to add some code to handle stopping and finalize the recording. So again, remember we've set up the signal handler, so when the user hits Control-C, we'll catch that, and then we'll call stop recording. We call stop recording, which is an AV foundation method, and when we call this, this will invoke the capture output delegate. Now a delegate method is just something that the operating system will call back. So we call stop recording, that tells the operating system or the AV foundation framework we're done recording, and then it'll call back into this delegate method, which we can implement. And here we call stop recording on the session, and then exit. So once we compile this code and run it, we can see it finds the default webcam, which is FaceTime HD. That's kind of the internal name for the built-in webcam on modern Macs. It's going to record until we hit Control-C. It'll capture that Control-C, save the output to disk, and then when we run the file command on it, cool, we're back. File command on it, we can see that we've just got a video file. Now, if you want to capture audio as well, turns out this is really easy. Again, you use AV Foundation. We first find the default built-in microphone using the same default device with media type API, and this time we pass it AV media type audio. And then once we have reference to that, we just add it to our capture session. And again, we compile and run this. It'll now save audio to the file system. Obviously, you can combine both audio and video into a single session if you want to capture both the user's video and audio. All right, so let's briefly talk about the webcam LED. So whenever people talk about malware and hacking webcams, this LED indicator light is always a very important thing to talk about. Obviously, because anytime the webcam is recording, this LED indicator light should and does come on. So we can see this question someone asked on Reddit, basically saying, how hard is it to disable this LED indicator light? And I think the answer is good. It's really not that scientific, but does show that, it's actually very, very difficult to turn it off. Basically, the LED indicator light, as we'll see, is completely separate from the operating system. It's on a separate chip, so you can't really access it in software etc., etc. Now, of course, nothing is impossible, so older versions of Apple's products, specifically some of the MacBooks from about 2008, which had the EyeSight camera, were vulnerable to an attack. So researchers at Johns Hopkins University basically detailed their finding describing this attack in a paper titled ICU Disabling the MacBook Indicator LED. And the first thing they did was describe the architecture of these EyeSight cameras, which again were the predecessors to the FaceTime HD cameras that are now in modern Macs. There's basically 4 components to the architecture. There's a host computer, which communicates to a USB controller. And this USB controller is a Cypress Easy USB microcontroller, and it communicates with an image sensor via I/O pins. And the image sensor is the device or hardware that's actually capturing the video input. Attached to one of these I/O pins, specifically the standby pin, is an LED light. And when standby is on, meaning the device is powered off, the LED indicator light is off. And when standby is off, meaning there's power to the image sensor, the LED indicator light is on. So the attack they pulled off was elegant in its simplicity. So it turns out that the USB controller could be reprogrammed anytime from user mode, which I think is kind of a security fail, right? So basically, you can send a firmware load request and load some malicious unsigned firmware on the USB controller. And then once the USB controller has this malicious firmware, it can reconfigure the image sensor. So it did 2 things. The first thing it did was it told the device to always keep standby on. And then it told the image sensor to ignore that standby and record video off it. So the end result is they could pull video off the image sensor, but the standby pin was still set to on, meaning the LED indicator light was off. So end result, because they were able to upload this malicious firmware and reprogram these components, they could record off the webcam without the LED indicator light coming on. Luckily, Apple fixed this, so in modern versions of Mac, I believe the LED indicator and whatnot is not programmable, or the firmware has to be signed. I haven't really dug into it, but as far as I know, it's pretty secure. Now, you might be wondering, what can you do to protect the webcam, your webcam? FBI tells us to cover it with tape, and actually, this is not a bad idea, and a lot of people do. It's cheap and effective. There's also camera covers you can buy on Amazon that allow you to kind of slide it on and off. Another option is disable webcam plugins. I don't know if I'm a fan of this method, but we're going to describe it for completeness. So the website OSX Daily has an article describing how to do this. Basically, 2 steps. You disable system integrity protection, and then you modify the access controls on the webcam-related plugins. Basically, you make them readable only by root, so then any application that tries to load them won't have access to them, and they'll fail. So, for example, if you try to fire up FaceTime or Skype, when it goes to load those plugins, it'll get an access denied. And the idea is malware would as well. Now, of course, if the malware is running, for example, at a higher privilege level, at root, it could change those permissions back, or if it's running in the kernel and directly talking to perhaps the AV code in the kernel, it wouldn't even have to deal with these plugins. So again, not that good a solution. All right, so that was some general background webcam and mic related concepts. I mentioned there is a bunch of Mac malware we'll now talk about that attempts to record users via the webcam or listen to their mics. So let's take a closer look at these specimens now. And as we'll see, all these specimens really not that sophisticated, so anytime they go to record off the webcam, the LED indicator light's gonna come off. So that's kind of a big giveaway, right? You're sitting at your laptop, like picking your nose or something, and all of a sudden this LED indicator light comes on, like that's a big indicator that something weird is going on. All right, for the first sample we're going to look at is Hacking Team's OSX implant. So Hacking Team is an offensive cybersecurity company from Italy that sold cyber capabilities to a variety of governments. A few years ago, they got hacked, and the source code for all their tools and utilities got leaked to the internet, which was nice because for malware analysts, generally we don't have source code, right? We just have binaries. But in this case, we got source code. So if we look at what their implant does, we can see it persists as a launch agent. Specifically, it calls itself com.apple.loginstorageagent.plist. And if we look at the file that has all the module names, we can see it supports a wide range of capabilities. And this makes sense because this was designed to be used by governments to basically gather all sorts of intelligence. So you can see there's modules for grabbing stuff from the calendar, the mic, taking screenshots, keylogging, camera, et cetera, et cetera. So let's take a closer look at the code in their malware that's responsible or performed recording off the webcam. So this was in a file named rcsm-agentwebcam.m. So it turns out they use Apple's Qt kit, which is deprecated. I think it's just because hacking team's code was rather old and they were probably familiar with these APIs. But yes, when this code is executed, it will record the user via the webcam. But of course, the LED indicator light will go on. The mic module implements code that can record off an infected computer's mic. And this is, again, separate from the webcam. Maybe they realized that when the light on the webcam goes on, it was a giveaway, so they decided to make the mic module a completely separate component, as sometimes they might just want to record audio without the LED indicator light goes on. Because if you just use the mic, there's no indicator alert that you're recording. Again, it doesn't use the AV Foundation, but rather an older framework called the Audio Queue Services. And Apple says this is a C programming interface in the Audio Toolbox framework, which is part of Core Audio. So it's just a lower level framework that allows you to record audio. All right, the next malware sample is Eleanor. This is a more recent Mac malware sample. It was discovered last July by Bitdefender. And it was distributed via the internet, so not via the Mac App Store. What the attackers did is they found an application that was abandoned, an application called EasyDoc Converter, and they created a new malicious version of this application and then uploaded it to the popular app sharing website, macupdate.com. So then at any time a user went to download this application, instead of getting EasyDoc Converter, they'd get a malicious version of the file, which then they ran would infect themselves. So what did this do? Basically installed the malware that communicated via Tor, and it served up a PHP web backdoor. So a remote attacker could connect via Tor to the user's computer and then execute files, commands, et cetera, et cetera. In terms of audio and video capability, the malware shipped with a variety of separate utilities, for example, Netcat, and then one called Waka. Waka is an open source utility on SourceForge that allows you to record users off the webcam. So what the attackers would do is they would basically just execute this utility via the PHP web shell that was on the infected host and then record the user. Next up, we've got OSX Smokes. This was discovered in September, so last fall, another pretty recent sample by Kaspersky. It's a cross-platform backdoor that supports a wide range of capabilities. So again, kind of more focused on intelligence gathering. So it was able to execute commands, had some interesting search capabilities. For example, it searched the file system for various documents and would exfiltrate those. It also monitored removable media. So if you plugged in a USB stick into an infected host, it could enumerate files and grab them off and exfiltrate them to the remote attacker. And then it also had the ability to do screen captures and audio and video captures off the webcam or mic. Now, we don't have source code for this malware, but we can reverse engineer it to see what it does. So we can figure out that for the webcam capture code, it's using the cross-platform Qt framework. And this makes sense because this specific piece of malware is a cross-platform backdoor, meaning it runs on Windows and on Mac. So by using the Qt framework, which kind of abstracts the OS-specific implementation details of how you do webcam recording on Windows versus Mac, the attackers don't have to worry about that. They can just call into the framework, which abstracts all those details as well, and record both webcams off both Mac and Windows devices. All right, finally, we've got Fruitfly. This was the first Mac malware sample from 2017. And it's rather interesting because it was distributed, or rather was a obfuscated Perl script that persists as a launch agent. So what the Perl script does is executes every time the user logs in. And within the Perl script is an embedded mock-O binary. So what the Perl script then does is it drops that binary to a temporary location and executes that. And what this does is it tries to talk to other devices on the network, which is kind of interesting, perhaps trying to further propagate or talk to other infected systems. So whenever the malware executes, it talks out to a command and control server and asks for tasking. So one of the instructions or commands that the attacker can give it is to record off the webcam. So if we reverse engineer the command handler, we can figure out how it's doing this in code. Turns out it's using Apple's QuickTime APIs, which are actually very old and deprecated. So it took me a while to get this all working. I wanted to write a proof of concept using these APIs. And the reason it's a little difficult to get working is first, Apple removed the header files from the latest SDK, so you have to go back and get an old version of the SDK. And then also, when you compile, they are only supported in 32-bit mode, so you can't build a native 64-bit application. But once you get this all built, yes, you will be able to record via the webcam. Again, the LED indicator light will go on, but it will succeed. Now, there was some discussion saying that maybe the attackers were using these older APIs to maybe not get detected, but it turns out that this malware has actually been around for a really long time and only was just recently detected. So it's likely that it was just flying under the radar, and whoever wrote this malware was familiar with these older APIs because, again, the malware is rather ancient in terms of malware. All right, so that was some recent Mac malware samples that are webcam or mic aware. And again, we'll try to record infected users. Luckily, as we've said many times, the LED indicator light will come on, so this is kind of a dead giveaway. So now I want to talk about an interesting attack that can potentially allow malware to record users without any alert. And we'll see basically what we can do is piggyback off existing sessions, and since the LED indicator light is already on, there will be no further alerts. So first, if we observe that Mac users do use their webcam. So yes, you can put tape over that, but that's not always the most practical example. So what are some examples of how Mac users will use their webcams? Well, business meetings. If you work remotely, you might talk to your team or call in for a board meeting. If you work, again, for a company, you might be doing remote R&D sessions where you're talking about new projects you're working on. You might be Skyping with source if you're talking to a journalist, or talking to a security team to report zero-day vulnerabilities. And again, a lot of people use FaceTime to talk to their intimate partners and whatnot. Now, I think the important thing to understand about this is these are the sessions that are probably most interesting to record anyways. Like, if you're always recording someone, you're probably just seeing them sitting at their desk, petting their dog, picking their nose, whatever. But, as a piece of malware or as a nation state, this is probably what you want to capture anyways, right? The intimate sessions where then you can blackmail the person, or while they're talking to, for example, a journalist to, get the information that they're kind of discussing. So conceptually, what our attack is going to do is pretty straightforward. So in 3 steps, we're going to wait until the user starts a legitimate webcam session. And then when the malware detects this, we're going to piggyback onto this session to begin recording. And then once this recording is complete, once the session is terminated, we're going to exfiltrate that captured audio and video to an attacker. And again, since the legitimate session is already established, there's not going to be any indication of this piggybacking event. So the first thing we do, or the first thing the malware needs to do, is enumerate and find that built-in webcam. And we talked about this already, how to programmatically do it, but just to reiterate, we can use Apple's AV Foundation. So this can be done in a few lines of code. Basically, you can call the devices with media type, and you pass in AV media type video, and this will return you an array of cameras. So you'll get access to the built-in one, or if they have an attached camera, you can get access to that device. And then once you have access to that device, you can start registering for notifications. So what notification are we going to register for? Well, we're going to register for when the webcam goes on or off. And we can do this with the CMIO object add property listener block method. So this method takes a variety of parameters. The first is a connection ID, which we can get from the camera. Basically, this is a private instance variable, but we can, in Objective-C, access that. And then the next thing we pass is the notification we're interested in, again, the on and off. And then finally, we pass in a callback block. So once we've registered this notification, when the notification fires, meaning when the webcam goes on or off, our callback block will be automatically executed. So what do we do in this handler? Well, we do a few things. Basically, we query the webcam to determine what the notification is, because the same notification will be delivered if the webcam goes on or off. And we're only interested when it goes on. So what we can do is we can invoke the CMIO object get property data, and this will set a value to 0 or 1 if the webcam is currently active or if it's deactivated. So that's what we do in this code. So at the very bottom, we can check the is running, and if it's running, that means we can now start recording the session. So now we know the user has initiated a legitimate webcam session, so we can begin recording. And this works because on modern Macs, the webcam is a shared resource. So like you can FaceTime and Skype at the same time. I'm not sure why you want to, but you can. So this obviously means our malware can do the same thing. So in code, it's very simple. Again, we can use the AV foundation to start recording off the webcam. And Apple makes no differentiation between using the webcam to broadcast yourself or record off it. So even if the user is just using the webcam to broadcast themselves, for example, they're chatting with their girlfriend or boyfriend, the malware can hop on and record off that. So again, we use the AV Foundation APIs. We create that capture session. We add input and output, and then we specify the file we want to start recording. And then once this is activated, the webcam will start streaming off the computer into our file. Now, equally important, we should know when the webcam is done. That is to say, when the application that legitimately initialized the session has terminated. Because it would be suspicious if the user ended their FaceTime session and the LED indicator light would still be on. So there's a variety of ways to do it. The easiest is just to register for application termination notifications, and then we can determine when the application exited. So we'll talk briefly about how we determine what application initialized or initiated the webcam session, because although we get a notification saying, hey, the webcam is now active, Apple doesn't tell us what application actually triggered that notification. So there's not like a PID or path in that notification. So let's, for now, assume that we were able to figure out what application triggered that event. So say it's FaceTime. What we can then do is just monitor and determine when FaceTime exits. So we can register that via the NS Workspace notification. We register for the NS Workspace did terminate application notification. And this will then call us back anytime any application exits. So we can just monitor application exits, and as soon as we see FaceTime or whatever application that initiated the webcam session, we can simply stop recording so that the LED indicator light doesn't remain on. So from an attacker's point of view, this is a great attack. Why? Well, first, it utilizes legitimate functionality of the operating system. We're not doing anything wrong, so it's really kind of difficult to patch or prevent. Also, you don't need root, which is nice, so any code that's running on the system can monitor for the webcam, piggyback onto it, and record off it. As I mentioned, you can also always record off the webcam, even if the user is just using it to broadcast themselves. And finally, as the LED indicator light is already on, there's no other secondary alerts or indication that this piggyback attack is happening. So as an avid Mac user, I love my Mac products, definitely have drank the apple juice. This kind of bothered me. And, yes, there's some tools that can tell you when the webcam is activated, which I think is kind of pointless because the LED indicator light is going on. There were no tools that would tell you what process was activating the webcam, nor any tools that could detect this piggyback attack. So I decided to write a tool. The goal of the tool is pretty simple. I basically want to be alerted anytime any process accesses the webcam, even if the webcam is already in use. And then I also want the tool to be able to identify what process is using the webcam. So yeah, the LED indicator light may be on, but I want to know, what application or process is the one actually using that. So it turns out we can do this in 3 pretty simple steps. We first register for webcam notifications, just like the malware does. And then when the webcam is activated, we can basically determine who, and we'll show this in a minute, activated that. And then while the webcam is in use, we just look for secondary consumer processes that might be piggybacking on to access the webcam while it's already in use. So the tool is called Oversight. It's totally free. I know people sometimes say, you know, there's always got to be a catch with free tools, and generally there is, but I wrote this tool first and foremost to selfishly protect my Mac. And then I figured sharing is caring, so yeah, 100% free. So what Oversight can do is it can detect when the internal mic or webcam is in use, and it can identify what process is then using the mic or the webcam. And then it can also monitor the webcam to detect these secondary consumer processes that might be maliciously piggybacking off it. And then it can also allow the user to block this access. So under the hood, we'll kind of dig into how this tool is designed. There's a few components. The first component is a login item. Login items will start automatically on startup. So this just means the application will automatically be executed when you log in to provide continual protection. It shows up in the status bar. There's a little icon you can click, and it has a little drop-down menu for configuration, preferences, and whatnot. What it does, this login item, is then monitor for these webcam and mic activations. And then it's also responsible for showing the alerts because it's running in the user sessions. There's a second component, an authorized XPC service. XPC service is just a service that talks via mock messages to another component, in this case, the login item. And what it does is it is responsible for determining what process activated the webcam. And then also, once the login item has shown an alert to the user, if the user clicks block, that message is sent to the XPC service so it can kill the process. Because you might have malware that's running as root. Login items run in the user session as the user, so they might not have privilege to kill the process. But we can send a message to the XPC service to tell it to kill the process, and then it is able to terminate that. So one of the main functionalities or feature points of Oversight is its ability to identify both initial and secondary consumer processes. That is to say, it can tell you what application is actually using the webcam or the mic. Turns out this isn't trivial because Apple doesn't provide any direct way to do it. So yes, they will develop, alert you, deliver a notification saying, hey, the webcam is activated, but they don't tell you what process is doing that. So if we reverse engineer this whole process, we can kind of figure out what goes on under the hood. So say an application like Skype starts using the webcam. Once it's activated the webcam, the OS will actually send a mock message, which is just an IPC message, to the camera assistant process. So Oversight has now got the notification that the webcam is active. So what it can do is it can query the camera assistant process and see who sent it recent mock messages. So then it has some candidate processes. One of them is going to be the process that initiated the webcam access. And then so once it has those candidates, it can query those. It can, for example, look at the loaded libraries and sample that process to see a thread stack trace, and then figure out dynamically which of those candidate processes is the one that actually is using the webcam. So not an exact science, but it works actually really well. So I released version 1.0 at the end of last year. It turned out to be a fairly popular utility. I think my favorite part is, for a while, if you Google Oversight, it actually beat out the US government. Well, specifically the Oversight Committee. So I thought that was kind of cool. Version 1, somewhat limited in features, so I got a lot of feedback and requests for improvements and new features. So the first thing was the initial version of Oversight, while it could identify what application was using the webcam, it couldn't identify what application was using the mic. So it just said, someone's using the mic. It also had no whitelisting. So say you use Facebook or Skype a lot, it would alert you every time you use one of those applications, which got a little annoying. Then also didn't have a command line interface. So today I'm releasing version 1.1, which has a slew of new features. And one of the main features is Oversight can now detect accurately and identify what process is using the microphone. Turns out this is kind of similar to how the webcam is detected, but there's a little more that goes on. So again, if we have an application like Siri that's accessing the mic, Oversight will get a notification from the operating system because we registered for mic alerts, and it'll say, hey, the mic just came on. So we know someone has started recording off the mic. What we can do then is, again, we can monitor these mock messages, and when someone talks to the mic, under the hood, the operating system will send a mock message to the core audio daemon, core audio D. So again, we can look at that and we can see what processes have recently sent mock messages to the audio daemon. We also then can scan the I/O registry because when processes talk to the mic, they register some entries in the I/O registry. And then similarly, we can perhaps sample the process or look what dynamic libraries it has loaded. So again, it's not an exact science, but seems to work very reliably. So for example, when you fire up Siri, it will now tell you that Siri, or Assistant D, which is what Siri is behind the scenes, just became active and has started to use the microphone. Another feature in Oversight 1.1 is the ability to whitelist processes. I mentioned this was a request for a lot of users. Again, something like Siri uses the mic, got really annoying when, every time you ask Siri a question, you would get an oversight alert. So now what you can do is when any of these processes accesses the mic or the webcam the first time, you get an alert. And if you click allow, it'll ask you, do you want to allow it always or just once? And if you allow always, it will add it to a whitelist. And then you can then go in and click manage rules to see what processes have been whitelisted. And then from then on, those whitelisted processes will be allowed. Now this is done via the XPC mechanism, so malware that's not running as root can't obviously just whitelist itself. All right, so since we have some time still, I want to dive into an interesting case study where Oversight revealed some interesting behavior in a very popular application. So it all started with an email from an Oversight user. They emailed me saying, thanks to Oversight, I was able to figure out why my Mac was always spying on me. Just to let you know, Shazam keeps the microphone active even when you specifically switch the toggle to off in their app. Scary. And this piqued my interest. I was like, yeah, this sounds kind of interesting. At the time, I was flying to Echo Party conference in Argentina, which is an awesome conference. And I was on a 15-hour flight from Australia. So no internet. I actually get a lot done on these flights. So I decided to dig in and see what was going on. So the first thing was I had a copy of Shazam. Shazam, you're probably familiar, but in case you're not, it's just an application that listens to audio, and then it can dynamically identify what song you're listening to. It's kind of a cool feature. It's mostly on our phones, but they have a Mac application, which is what the user was talking about. Again, he claimed that when you turned it off, the microphone was still active. So when I downloaded it and installed it, it automatically starts running, and I got an alert saying, hey, Shazam is using the microphone. This is expected because Shazam is going to listen to audio and identify the song. So far, really nothing too suspicious. I then turned off Shazam, and as the user had reported, I got no deactivation alert. So Oversight will normally tell you when the webcam or mic goes on, and then also when it gets off. In this case, though, I didn't get an alert. So I thought, okay, there's two options here, right? The first is they might still be listening, or there's a bug in my code. Either way, long plane ride, I decided to dig into this. So first, let's talk about the various components of Shazam. So when you grab Shazam from the App Store on your Mac and install it, if you have a utility like BlockBlock, which we'll talk about in a few slides, it'll give you an alert saying, hey, Shazam is installing a persistent login item. And if we look at the Shazam app bundle, we can see in the library/login items folder, there's a utility called Shazam Helper. Now, any application that you install, if there is a binary in this library/login items helper, the operating system will automatically execute that every time the user logs in. So this is how applications distributed from the Mac App Store can legitimately persist components. So this basically means every time Shazam, the user logs in, that Shazam helper process will be executed. So let's take a closer look at this login item to see what it does. So we have the disassembly from it, specifically in the application did finish launching method. This is kind of like an application's main function, automatically executed when the application is loaded. And on the right, I have some pseudocode, probably easier to read, and we see it does two things. It creates a URL, Shazam mac://launch, and then opens this. And this then executes the main Shazam app, which is responsible for showing the item in the status bar and having the on-off toggle switch. Now you might be wondering, how does just opening that Shazam launch URL trigger the execution of the main Shazam application? Well, if we look at the info.plist file of the main Shazam application, we can see that there is a key, CF bundle URL schemes, that has a value of Shazam Mac. This basically tells the operating system, hey, I can handle URL schemes of type Shazam Mac, so if anyone opens a URL of this type, execute me so I can handle that. So again, this is how the login item launches or kicks off the main Shazam application. All right, so now we know how Shazam is automatically started. Again, recall our goal is to figure out if Shazam is listening when we toggle it to off. So let's first talk about how we can figure out what code is executed when the user toggles that switch on or off. Now, since Shazam is a MacOS binary, I believe it's written in Swift, this means it has a ton of really interesting content in the actual binary. So binaries that are written in Swift or Objective-C have a lot of runtime type information within the binary. For example, class and method names. So we can use a utility like class dump to extract this information. So we execute class dump, and we can see, for example, we get class names, instance variables, and method names. And there's this one method called toggle auto tagging that looks interesting. So let's debug that. So what we do is we launch this Shazam application, or if it's already running, you can attach to it. We use LLDB, which is the kind of de facto Apple-approved debugger for Macs. And what we do is we set a breakpoint on this toggle auto tagging method. And then once this is set, we go back into the UI and we toggle the switch from on to off. And turns out this causes our breakpoint to be hit. So awesome, this means this method is executed when the user toggles that switch. Now, once we hit that breakpoint, we can dump various values, for example, register values. There's a table on the slide that shows what register values have once it hits an Objective-C method call. So RDI is going to contain the name of the class, which is sh main view controller. The second argument is in RSI, that's the method name, and we can see, yes, it's toggle auto tagging, which is the name of the method we set the breakpoint on. And then most importantly, the third argument, which is in RDX, is going to be the parameter that that method takes. And if we do PO, which is print object, we can see it's an instance of something called an IT switch. And that is just the object that Shazam uses to represent that toggle switch. Now, since we have access to an instance of that object, we can invoke methods on it in the debugger. So for example, we can execute the isOn method, and we can see it returns no, and that's because we've just toggled the switch off. So again, we found out what method is called when it's toggled, and we also have access to the actual switch object. All right, so if the user toggles the switch from on to off, we can see that the toggle auto tagging invokes a variety of methods. And you can kind of follow it on the slide. It first invokes a stop tagging method, which calls another class's stop tagging method, which is in the Shazam SDK framework. That in turn calls stop tagging for reason. And then step 5, that calls stop tagging common. And then the most important thing, though, is the bottom left of the slide. And we can see there's this chunk of code that calls stop recording. But stop recording is only called if should stop recording when tagging ends, which is another method, returns true. So just remember that fact. So let's first look at that stop recording method. If we disassemble that, we can see it calls Apple's audio output stop function. The SDK docs from Apple say that audio output unit stop stops an IO audio unit, which in turn stops the audio unit processing graph that is connected to, blah, blah, blah. That basically just means it's going to stop recording off the mic. So yeah, it looks like reasonable. Maybe Shazam actually does stop recording when you toggle it off. But again, recall that stop recording only gets invoked if that previous method is true. So let's look at that previous method, which is, again, should stop recording when tagging ends. As we can see, it's a very basic method. It simply returns a Boolean yes, no value if some tagging type variable is set to or not. Now, when we toggle that switch, we have a breakpoint, so we can step into this and we can see what the value of that tagging type is. And we see when we dump it, it's not 2, it's 1. So that means that this method is going to return false, which means stop recording is not going to be called. Now, when reverse engineering things, we can't always be 100% sure of everything. So I thought, hey, maybe this method is returning 1 because I'm debugging it, or I'm running in a VM, or maybe it's not connected to the internet. So I decided to dig around a little more. First thing I noticed, though, is this tag value is set to 1 in a hard-coded manner. So it doesn't appear that it can ever be 2 anyways. So that was kind of interesting, because it kind of confirmed that theory. What we can also do is we can ask Shazam itself if it's recording. So it has a method called isRecording that you can invoke from the debugger. And I invoked this method after I toggled the switch to off, and it came back and said yes. So this is basically the Shazam app telling me, hey, I'm still recording even though the UI is toggled off. So at this point, I felt pretty confident. Emailed Shazam. I was like, hey guys, looks like your app is still recording even I turn it off. Like, what's going on here? And they basically came back and said, yeah, we use this continued recording on iOS and Mac for performance, allowing us to deliver faster song matches to user. So again, like the whole BS performance excuse. Now, there's a few things to know. First, I don't think Shazam is being malicious per se. I don't think they were spying on anyone. Because while they do continue to record, so while they are pulling audio off the mic, they don't actually process it if the user has toggled the switch to off. So again, what Shazam does is read audio off the mic, and I think they send it to the cloud for song identification. So when it's off, it actually doesn't exfiltrate any of that. So that's, not necessarily the worst. And also, it turns out that the way they pull audio from it, they might be more doing sampling versus doing full room collection audio. So I'm not sure if you can actually rebuild actual conversations. But either way, the problem was they were still pulling audio off the mic, which I don't think is good, especially if they have this off switch. So again, I reported this to Shazam, and they basically said, oh, this is a feature, not a bug, yada, yada, yada. The media picked up on this, and of course, they like to make things a little more sensational, like, oh my God, Shazam is spying on all of us. But the good news was this caused Shazam to actually change their behavior, which I was very happy with. So what they said is we updated the application to make sure the microphone is completely turned off when Shazam isn't running. So this was good. Now when you turn Shazam to off, it actually stops using the mic. So this was cool. I thought this was, illustrated that Oversight was a useful tool, but also I think it revealed some somewhat shady functionality of a legitimate application and eventually caused the vendor to, remedy that. All right, so let's start wrapping this all up. But before we end, I briefly want to talk about some generic detections. Why? Well, I think we just illustrated the value of such generic detections. For example, monitoring is the mic off. We revealed that a legitimate application was doing some kind of shady stuff. Also recall the Mac malware samples we talked about earlier in this presentation. None of them, as far as I know, were detected via static antivirus signatures. That is to say, if you had antivirus running on your computer and one of these samples infected you, it wouldn't detect it. So this kind of bothers me. And we're all aware of the limitations of antivirus products, right? They only detect known samples, and they're trivial to bypass. It's even exasperated on Macs because while Windows AV products often have a lot of behavioral heuristics and sometimes can detect new samples, I've talked to a lot of AV vendors who are basically like, yeah, we don't put that much time and money into our Mac products, so it's pretty much a signature-based system. So I thought it'd be cool to kind of look into some generic detections and write some tools that might allow us to detect new malware. So the first thing I kind of made the observation is that Mac malware persists. So all the samples we talked about that monitor users via their webcam and mics, as well as other Mac malware samples, persists in some manner, meaning it automatically can be re-executed every time the operating system restarts. So the first free tool I wrote is called Knock Knock, and if you're familiar with auto runs on Windows, this is exactly the same, but on Mac. So I'll show you all the software that is persisted on your computer that is automatically set to run, both legitimate ones and ones that might be malware. The other tool I wrote is called BlockBlock. Again, this is free, and what it does is it monitors these persistence locations. You can kind of think of it as a firewall for persistence. So anytime something tries to persist itself on your computer, you'll get a pop-up. So when you install Shazam, it'll say, hey, Shazam installed a component that's automatically running. And then you can say, oh, that's fine, I'm okay with that, or you can block it. And the cool thing about this tool, since it's been released, every piece of malware that's been detected after that went to persist, this tool would detect. Because again, it's not trying to detect malware per se, it's just detecting persistence. Another thing that I think we should be able to generically detect and thus prevent is ransomware. So I wrote a blog about this last year called Towards Generic Ransomware Detection. And I made the observation, the rather obvious observation, that ransomware creates many encrypted files, often very quickly. So I wrote another free utility called Ransomware, WHERE. And what it does is it monitors the file system for the rapid creation of encrypted files by untrusted processes. And then anytime it sees this, it just pops up the user and says, hey, this process has created 2 or 3 encrypted files, like, are you cool with this? And yes, some users will click yes, but hopefully, some users will click no. So again, this is able to generically detect all known versions of Mac ransomware, because again, it's not trying to detect the malware per se, but the behavior of it. So these tools are available on my Mac security website. They're all free, so I hope this doesn't sound like a sales pitch. Again, these are tools I run on my computer to protect it, especially when I travel. Figure sharing is caring. So we mentioned knock knock, block block. There's some tools to detect dilib hijack scanners. Task Explorer is kind of like Process Explorer on Windows. And if you love these tools, I have a Patreon page, so if you want to support them, I would be forever grateful. All right, so that is a wrap. Thank you so much for attending my talk. And again, if you're interested in being a freelance hacker or researcher for Synack, check out synack.com. And we also have some Synack t-shirts, I believe, that we're going to hand out after the talk. So we still have about 5 minutes, so if there's any questions, you can answer those now, or you can shoot me an email, or I'll be around the rest of the conference. But again, I really appreciate you attending my hour-long talk.
Any questions? Well, oh, yes.
Yes.
Hi, thanks for the talk. So you mentioned about Shazam and how you detected that it didn't turn the mic off.
Yep.
So they have an iOS app, right?
Yep.
And whatever you did, you only did on Mac.
Yep.
So how different would it be to make that work on iOS? Is it the same components that you use for webcam access and?
Yeah, as far as I know, the code is pretty much shared. So, their original email said that they do it mostly for performance on iOS. I didn't dig into that, but yeah, it's kind of interesting. But again, there's AV Foundation for iOS. So like the sample codes in these slides or on Stack Overflow for recording stuff are mostly actually for iOS because people are more interested in doing that. What I believe though is I think there's a pop-up on iOS that's like, Shazam wants to access your microphone. But of course you're probably gonna let it because that's what it does. My understanding though is when you basically background the application, it's gonna stop recording. Like the operating system basically stops it from executing. But while Shazam is in the foreground, it probably is just recording all the time. So I'm guessing that's kind of why it happened on Mac. They basically said, oh, on iOS, when someone's done using Shazam, they'll hit their home screen. That will background the Shazam app, which will cause it to stop listening. But on Mac, there's not that really concept of terminating or backgrounding applications, so it just kept pulling off the mic. So I don't think the Shazam one's always spying on you, but I mean, I didn't think the Mac one was either, so be an interesting thing to look at.
And about the performance issue, like how hard is it to get access to the mic every time your user wants you to?
Yeah, exactly. I think what their reasoning was is probably they started for iOS and ported it to Mac and just didn't want to change the code. But I guess the logic would be they could continue listening the entire time and have a buffer. So when you say, what song is this? They could pre-process the previous 5-6 seconds and then answer right away versus having to wait 10 seconds and then tell you. But yeah, it's, I don't necessarily really buy that. I would rather, like, when I turn it off, it be off. So I'm glad that they fixed it after the media gave them some shit. So I guess all's well that ends well.
Any other questions?
Good talk. Are your tools open source that you've written?
That's a great question. So some of them are, some of them aren't. The reason is just IP-based stuff. So Oversight is not, but I try to really describe exactly how it works. Moving forward, I think I'm going to start open sourcing my tools. Like I said, I'm on Patreon, so I have people donate and support, so it's kind of like, oh, you know, there's kind of some more financial incentive. Any of the tools that have kernel components, I open source all the kernel components. Tools that persist or have any network connections, I document all that. It's just a version check. It doesn't send any information about that. But again, I understand like security tools ideally would be more open source. So that's something I'm trending towards because I think that's kind of the way to go. And for some tools, there's actually open source versions. So for example, Knock Knock, there's a Python-based version I wrote that's on GitHub. The dilib hijack scanner, there's a command line version as well. But yeah, like I said, moving forward, I'd like to do more and more open source stuff because I think it's kind of the ideal scenario. Good question.
Thank you. Any other questions? Or feel free to email him, as he said, if you're interested to join a red team or have further questions.
Yeah,
Thank
bug
you
me
very-
anytime.
Thank you.
Thank
Thank
you.
you very much, Patrick.